Hi everybody, welcome back. Today we're going to look at trigonometry. And I'm not sure if I'm going to split this into more than one video. So let's just start off with Pythagorean's theorem. We'll see how long the video goes, and then we'll decide at that point whether or not we should split this into two videos. Okay, so this is Pythagorean theorem. It states that given a right triangle, and remember a right triangle is a triangle with a 90-degree angle in it. Okay, so supposing I give you a right triangle, and I label the sides. Perhaps I call that one A and that one B. And then this side, we're going to call this side C, which is the hypotenuse. Okay, in this case, we know the sides have the following relationship. The sides have the following relationship. A squared plus B squared equals C squared, like so. Okay, now just one important thing to note here, well maybe two. The side opposite to the right angle, this side here, this is always the hypotenuse. That's always the C value here. And then A and B, it's arbitrary which side you call A and which side you call B. So I could call that side A and that side B, and this relationship would still hold. Okay, all right, so let's look at two quick examples. Let's use Pythagorean theorem. Should probably capitalize that. To find the missing side. Right, so perhaps I give you this triangle, and I tell you this side equals 3 and this side equals 4. Then in this case, we're looking for the hypotenuse. We're looking for the C value, and we just do the following. I say, okay, well, let's let A equal 4, and we'll let B equal 3, and then we can use this relationship here. I know that 4 squared plus 3 squared equals C squared. And then if I simplify the left-hand side, what am I left with? I'm left with 16 for 4 squared and 9 for 3 squared. So altogether this adds to 25 equals C squared. And then at this point we take the square root of both sides. Okay, now usually when we do this, we're interested in the positive and negative solutions. This is an equation. I can see that minus 5 and 5 satisfy this equation, but in this case we're looking for a length, so it should be positive. So we're just going to say that if I take the square root of both sides, and I'm only looking for the positive result here, I just get this, that and that cancel, and we're just left with C equals 5. Good. Okay, so let's try another example here. Let me just separate the paper here. Okay, so for example, let's find the missing side for this. Okay, so in this case, maybe I would say, okay, well, c equals 1, that's clearly my hypotenuse. I'm looking for the side A here, and I know my side B is equal to 1/2. Okay, so if we set up our equation, what do we get? We get a squared plus b squared. A is unknown, so I'll just leave it as a squared, plus b squared, which is 1/2 squared, equals c squared, which is 1 squared, like so. Okay, now at this point I can just start solving for a. Okay, 1/2 times 1/2 is 1/4. 1 squared is 1. And then if I isolate a, the first thing I would do is subtract 1/4 from both sides. Okay, 1, that's the same as 4 over 4 minus 1/4. And that leaves me with a squared equals 3/4. And now I take the square root of both sides. And those cancel, and I'm just left with this. Okay, remember our radical rule here, because it's such a radical rule. Sorry, I forgot to make that joke already. But the square root of a over b can be written as the square root of a over the square root of b, like so. And therefore, we're just left with a equals root 3 over root 4. And then this gives me a equals the square root of 3 divided by 2. Okay, so what's our time at here? Well, it looks to me like our time is just about 7 minutes into this video, so let's at least begin the next topic here. Okay, the next topic is going to be the trigonometric functions. And you may remember this as SOHCAHTOA. SOHCAHTOA. And it just says this: given a right triangle with angle theta, that's my angle theta. Well, in this case, I'm still going to call this side the hypotenuse. Just write HYP for hypotenuse. And the side opposite to theta, this side is opposite to theta. Okay, that side, that's the opposite side to theta. And then this side, we'll call it the adjacent side to theta. Okay, so we always talk about these sides with respect to the angle given. Okay, now if I were to call this angle alpha, for example, then in this case, this would be the opposite side to this angle here. Okay? All right, so given this right triangle, the three trigonometric functions measure the ratio of the sides based on the angle theta. And they are sine of theta is equal to opposite over hypotenuse and then there's a second one, cosine of theta equals ka adjacent over hypotenuse. Okay, and then there's a third one. Actually, there are even more than this, but these are the three main ones. Tangent of theta, or tan of theta, equals opposite over adjacent. Okay? All right, so let's just practice using these to make sure it works, and then we'll look at solving questions using these. Okay, so let me give you the following triangle. For example, if I give you this triangle, and I tell you this angle is 30 degrees, and the hypotenuse here is equal to 1, and this side is equal to 1/2. Let's just confirm that the trigonometric functions work here. All right, well, let's see here. What do we have here? We have this half, that's the adjacent to 30, or sorry, the opposite to 30 degrees. So we have opposite to 30 degrees equals 1/2. And then I have this hypotenuse here. I've got a hypotenuse equal to 1. And then at this point, if I were to use the trigonometric functions, well, I know that sine is equal to opposite over hypotenuse. So I have that sine of 30 degrees is equal to the opposite divided by the hypotenuse, which in this case is 1/2 divided by 1, which equals 0.5. Okay, so what do the trigonometric functions do? Well, it tells me exactly what that ratio is. So let me just pull out a calculator here. Okay, so let's just see what happens when we punch in sine of 30 degrees. Sorry, just try to get this to focus. There we go. Okay, so I'm going to do, okay, now make sure you're in degrees. If I were to push rad here, it takes me out of degrees. This is, rad is radian measure for an angle. Degrees is what we're currently in. So if I do 30 and I take sine of 30, as you can see, I get 0.5. Okay, so what these trigonometric functions do is they just measure the ratio of the sides according to the angle theta. Okay? All right, so let's try that again. Well, the point I'm trying to stress here is this. If I were just to extend each of these sides by a factor of 2, what would happen? Well, if I were to extend both these sides by a factor of 2, but I didn't change the angle itself, if I extended that by a factor of 2, that would give that a length of 2, and then all of a sudden this would have a length of 1 here. And again, what that would tell me is, well, if I did cosine of 30 degrees, or sorry, sine of 30 degrees here, okay, which is opposite over hypotenuse, I would still get 1/2. Okay, so these trigonometric functions, they just tell us the ratio of the sides. They don't actually tell us the value of any one side. Okay, and how we're going to use this is we're going to use it to solve similar triangle, or sorry, we're going to use this to solve triangle questions. Okay, all right, so let's write this. Now let's just say this. So we can use to solve right triangle questions. As long as we're given one side and one angle. Okay, so if I have one side and one angle, I can solve any right triangle problem. Okay, let's give this a shot. So for example, let's find the missing side, or the missing sides. For the following triangle. Okay, supposing I give you a 45-degree angle here, and this is a right triangle, well then obviously we know that's 45 degrees. And I tell you that the opposite side is equal to the square root of 2. Okay, now in this case, we want to find the missing sides. Find the missing sides. So as of this point, we've got the opposite side. Okay, that's my opposite side. So if I want to solve this question, I'm going to want to use either sine, because that has the opposite side in the formula, or I want to use tangent, TOA. All right, let's try using tangent here. Okay, so for tan of theta, I know that tan of 45 degrees is equal to the opposite side divided by the adjacent side. But here I know the opposite side is the square root of 2. And let's call this side, this is our adjacent side, let's call this x. Let's call this our adjacent side. Okay, now if I solve for x here, I'm going to multiply both sides by x. And that cancels the x's on that side. And I'm left with x times tan of 45 degrees equals the square root of 2. And now I'm going to divide both sides by tan of 45 degrees. And this is basically cross-multiplying here. I multiply the x to that side and the tan of 45 degrees to the other side. Or sorry, I divide it to that side. Okay, so these cancel. Tan of 45 divided by tan of 45 equals 1. And this gives me x equals the square root of 2 divided by tangent of 45 degrees. Okay, now we need to do this in our calculator, but this here, we would call this an exact answer. Okay, we're expecting an irrational number here, so that's an exact answer. Okay, and now we're going to do an approximation. Actually, we're not going to do an approximation because I know exactly what the answer is here. Let's see how this works on the calculator. Okay, so I need to do the square root of 2 divided by tan of 45 degrees. Now, I must admit here, I just have an iPhone, okay? So the order of operations here is something you need to pay attention to. So if I were to do this on my iPhone, I would do this: the square root of 2, which gives me 1.41421 blah 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 blah. Okay, remember that value. And then I would say divide by 45, but then I would hit tan, and that gives me 1. Okay, and then equals to actually do the division. Okay, so tan of 45 degrees in particular equals 1. And then, as you can see, our answer is just the square root of 2. Okay, so in particular, I'll do this one more time. Tan of 45 degrees equals 1. Let's just confirm. 45 tan equals 1. So I end up with the square root of 2 divided by 1, which is just the square root of 2. Good. Okay, so we found the adjacent side. We found the adjacent side here. Just going to start a new piece of paper. Okay, so now at this point, let me just draw the triangle again. So at this point, we have this much information. Well, we've got almost everything at this point. I know that the adjacent side is equal to the square root of 2. And I know the opposite side is equal to the square root of 2. And you know, the angles in a triangle add up to 180 degrees. And if that's 90 and that's 45, that must mean that this is 45 degrees. Okay, now I just need to find this side length here. I need to find the hypotenuse. So in this case, I can use cosine or sine. Okay, and let's use cosine since we haven't had a chance to use it yet. Okay, so what do I know? I know that cosine of 45 degrees equals adjacent divided by the hypotenuse. And again, that's our hypotenuse. And our adjacent side is the square root of 2. Okay, now I'm going to do the same thing. I'm just going to multiply the hypotenuse to there, and then divide cosine of 45 degrees to that side, which gives me this. My hypotenuse is equal to the square root of 2 divided by cosine of 45. And I happen to know the answer here. I do believe it's 2. But let's just confirm. Okay, if I do the square root of 2, I get that. And then I need to divide by cosine of 45 degrees. And then equals, and we get 2. Okay, so this tells me that the hypotenuse is equal to 2 here. Good. Okay, I do believe you're set up for the trigonometry tutorials at this point, so work your way through the worksheets. They're fairly straightforward, I think. And then if you have any problems, let me know, and I'm going to take another look at them as well to see if there's anything I missed. In particular, I'm wondering if there are inverse trig functions, but at any rate, this is a 25-minute video at this point, so we'll call it quits on this for now. Okay, I'll see you again.